in your book, it's number system. Second chapter is polynomials. Okay, we are going to pick today polynomials. Let's see what exactly is polynomials. Okay. Okay, so polynomials. Just a moment. Okay, just a moment. Yeah, so at first you need to know, okay, like algebraic expression chapter you have learned, the concept you have learned in the previous class, right? So if I'll write x plus xy plus z, it's an algebraic expression, right, Gauri?
Yes, ma'am.
Okay, if I'll write x square plus y square, this is also one of the example of algebraic expression, right?
Yes, ma'am.
Okay, now here we are going to discuss polynomials. So we will be checking that the first one, this first algebraic expression, can we call it polynomial or not? Then the second example, can we call it polynomial or not? Okay, so there are two very important conditions, okay, which we need to keep in mind while checking any algebraic expression is polynomial or not. What are those conditions? Okay, let's see. So the first condition is this chapter is all about polynomial in one variable. Okay, so polynomial in one variable means here for the first example we can see x is there, then x and y both are there, then z is there. Okay, so three variables are involved over here, that is x, y, z. And in this chapter we will be sticking with polynomials in one variable. In one variable means the second one, again two variables I can see, x and y. Okay, so polynomials means it has to be one variable over there. For example, our polynomial will look like x square plus x plus 20. Here we can see x. Okay, power can be anything. Okay, first we are having power 2, then we are having power 3 or 4 or 5. But one variable means only one type of variable must be involved, and here we can see only x is involved. So this is very important condition. When we are checking polynomials, we must be checking polynomial in one variable. One variable has to be there, not two three different types of variable. Now if I am saying one variable, you must be clear, you should be clear that what does that mean. That doesn't mean that only one x you can see, no. Okay, you can see x so many times, that's fine. But okay, other variable y, z, t, u, v, it must not be there. If y is there, only y must be there, like y cube plus y square plus 2y plus 32. This is one algebraic expression where one variable, that is y, is involved. Making sense? So this is the first condition. Okay, and the next condition is we will be checking each and every variable's exponent. Okay, I am writing over here, what are we going to check? Each and every variable's exponent. So first we will check only one type of variable must be involved, and then we will check only what are the exponent of these variable. So see, again I am repeating what I am trying to say. We are checking the power of the variable. Power of the variable, we are not checking the power of the number. Okay, here you can clearly see 32 is sitting over here, I'm not going to focus on that. Or maybe 2 you can see over here, I'm not going to focus on that. I will be focusing on, we will be focusing on variables exponent. Okay, so here you can see why variables are What are the variables? So we can see so many y's over here. This is a variable, this is variable, this, the purple one is variable. Each and every variable's exponent we will be checking. Okay, before proceeding with the exponent, is that a whole number or not? Can you tell me what is whole number?
Ma'am, the numbers from 1 to infinite are called whole
1 2
numbers.
3 4.
No, like from 1, starting from 1 to infinite.
Starting from 1 to infinite, 0 is not whole number.
No.
0 is whole number. Okay, just yes, whatever you say, that is correct. You say that is all the counting number 1 2 3 4, these are whole number. Yeah, okay, counting number 1 2 3 4, you must have, like the way we count the number 1 2 3 4 5 6 7 8 9 10, yeah, till infinity. Okay, all these counting numbers are whole number including 0. Okay, so whole number starts from 0. Natural numbers are this, starts from 1. Okay, getting it? Yeah.
Yes,
So
ma'am.
we will be checking each and every variable's exponent has to be a whole number. Okay, each and every variable we will just focus with where we are having the variable. The first one is y cube. The next one is y square. The next one is, okay, 2 multiplied with y. So we will be just focusing on y, the purple one. Okay, and then we will check what are the powers. So exponent, the first one is having 3. Is that a whole number? Is it a whole number?
Yes, ma'am.
Yes, that's a whole number. Next one is having exponent 2. Is that a whole number?
Yes, ma'am.
Yes. Next one is having no exponent. Okay, so what is the exponent over here? If I will ask you what is the exponent over here at the place of question mark?
1.
Yes, here the exponent is 1 and still it is whole number. Each and every variable's exponent is a whole number. Hence, this is polynomial. Yes, it is polynomial. Getting it?
Yes, ma'am.
Okay, so two most important conditions are, first, one and only one type of variable has to be there. One type means we understand what does that mean. Okay, so many times y can be there, but okay, y z x u v all mix up will be there. That is algebraic expression. That is not polynomial. Okay, next, each and every variable's exponent has to be a whole number. Okay, let's take few more example. So if we are having y to the power, suppose 5 plus y to the power 7 minus y to the power 6 plus 8, is it a polynomial?
Yes, ma'am.
It is. Okay, it is a polynomial. If I'll give you one example, that is x to the power 10 plus x to the power 2x to the power minus 11 plus 13, is it a polynomial?
No,
Why?
because it has the power of like minus 11.
Exactly, and that is an integer, that is not whole number, right?
Yes, ma'am.
Okay, so each and every variable's exponent has to be a whole number. Here we are having negative 11, that is not a whole number. Due to that reason, this is not polynomial. Let's take few more example. So before proceeding with the next example, or maybe let me write it this way, that if we are having under root x plus 23, is it a polynomial?
Um, Ma'am, I'm not sure about this.
Okay,
Maybe.
so there is a rule. Square root, cube root, you have learned in the previous class. Now here there is a rule which we will be discussing in first chapter as well. So the rule says that when we are having a square root of x, it can be written as x to the power 1 by 2. When we are having, suppose, cube root of 7, it can be written as 7 to the power 1 by 3. Okay, in we are just writing it in exponent form. We are not changing anything. Okay, we are just writing it in exponent form. Same thing we are writing in exponent form. If we are having, suppose we are having a perfect square number. Okay, root 36. Okay, you understand here, even if I will write 2 or not will write 2, it's the same thing, right? Yeah, so this one can be written as 36 to the power 1 by 2. Okay, if you are having fourth root of 23, it can be written as 23 to the power 1 by 4. Making sense, Gauri?
Yes, ma'am.
If we understand this logic, then we will say that the given algebraic expression, this one, can be written as root x means x to the power 1 by 2 plus 23. And now, is it a polynomial?
No.
No, because the power is not a whole number, right?
Yeah.
Yes. Okay. So whenever we will be having a question that identify whether the given expression is polynomial or not, we will take a pause and we will think that whatever way it is given, are we able to check the exponent? If not, we will be just writing it like this if required, and then we will be checking the exponent, and then we will decide whether it is polynomial or not. Let me give you few more example. Before proceeding with the next example, I must show you few more rule of exponent, which again we will be discussing in the first chapter. So don't think that you have not learned this rule. We will be discussing these rules. Whatever I am going to tell you, again we will be taking it in the first chapter properly. Okay? So the next rule is, these are laws of exponent. Laws of exponent, or you can say that rule of exponent. Okay. So the rule says that anything having power 0 is 1. Okay. The rule says that anything having power 0 is just 1. Okay. Again, I'm writing x plus y also to the power 0 means nothing. Okay. X plus y doesn't exist. The result is 1. 1 crore to the power 0 is 1. Okay, 1000 to the power 0 is 1. So anything to the power 0 is 1. Okay, so this is also one of the rule. That means whatever you can see over there, that doesn't exist. Power 0 means it's not there. Only it's just our eyes can see it, but it's not even there. Okay, and the result is 0. Sorry, the result is 1. Okay, so let's use this example. I mean, let's use it in an example. So suppose we are having just 234. Now if I am asking, is it a polynomial? Is it a polynomial, Gauri?
No, ma'am.
Okay, so let's process it. Okay, so I said whenever any question will be given to us, and the question will be identify whether it is polynomial or not, we will take a pause and we will think about it. So we are taking a pause and we are thinking 234, it's just a number. Okay. So one thing we can think about, we can, we are going to take it like this. Can we write 234 as a 234 into 1, Gauri? It's the
Yes,
same
ma'am.
thing. 234 and 234 into 1. It's the same thing, right?
Yeah.
Okay. Now this 234 into 1 can be taken as 234 into 1 means, can I write x to the power 0?
Yes, ma'am.
Okay. And in your previous class, you must have learned that 24 into x and 24x is the same thing, right?
Yeah.
So now we can write it as 234x to the power 0, right?
Yeah, ma'am.
Now if I am asking you, just look at this one and tell me, is it a polynomial?
Yeah, ma'am.
It is, because whole number power has to be a whole number. Whole number starts from 0, and now we can say, yeah, it's a polynomial. So whenever any constant number from now onward will be given to us, okay, from here only directly we will make the conclusion. Directly we will write, okay, yes, it is polynomial. 234. Okay, any number will be given to us and we will make the conclusion without these all the things we are understanding. Okay, these are just mind map. These all the things we are just for understanding. Okay, we are not going to tell anybody, or nobody is going to ask us. Okay, When I will give you a number 2, is it a polynomial? Gauri, you will say yes. Okay. If I will say 32, you will say yes. If I will say 54, you will say yes. In case I will take y and I wanna check why it is polynomial, so you will say 32 can be written as 32 into x to the power 0 or maybe y to the power 0, and due to that reason it is polynomial. Making sense?
Yes, ma'am.
Okay, so direct question will be there, MCQ question will be there, like this: a number and identify whether it is polynomial or not. So we will just say yes or no. Okay, now the next rule. This is the one of the rule which I was talking about, law of exponent, which you need to know for checking whether the given expression is polynomial or not. And the next rule, okay, the next rule says that we will master this rule. So it says that an a to the power minus m can be written as 1 by a to the power m. Okay, let's try understanding this rule. We need to understand it really well. Okay, so let's focus on this one. A to the power minus m means 1 by a to the power m. The rule says that 2 to the power minus 5 can be written as 1 by 2 to the power 5. Okay, actually the rule says that whenever you are having a number, okay, and the power is anything can be the power. Okay, the exponent can be a positive number or maybe a negative number. Okay, when you are switching the place of the number from numerator, if you are going to write it in the denominator, okay, then is that allowed in mathematics? Yes, that is allowed in mathematics. We just have to reverse the sign of the power. So here on the left side, you can see 2 to the power minus 5 is sitting in the numerator. Yes or no? We are shifting it in the denominator on the right side. So we can do so. Okay, it is completely okay. It is allowed in mathematics. We just have to reverse the power sign. If it was negative, now it will be positive. If it was positive, now it will be negative. So when you are switching the place, let's take few more example and let's master this. So if you are having, suppose you are having 4 by 8 to the power 2. Okay, and this 8 to the power 2, for any reason you want to take it in the numerator. Okay, so mathematically is that acceptable? Yes, we can do so. 4 will say that yeah, you can sit beside me with multiplication sign. But this power will reverse its sign. Making sense?
Yes, ma'am.
Okay, if the power was positive, it will be negative. If the power was negative, it will be positive. When we are changing the place from numerator to denominator, or maybe from denominator to numerator. Suppose we are having over here 5 to the power 3 by 8 to the power 7. Now this 8 is telling that I want to go in the numerator, and 5 is telling that I want to go in the denominator for any reason, for any calculation or representation, whatever. So 8 will go in the numerator. We will be having 8 to the power minus 7, and 5 will come in the denominator. We will be having 5 to the power minus 3. Making sense? Okay, so this is how we will use this rule. Now I'm going to take example. Suppose we are having 2 by x plus x square plus 32, and we are, well, the instruction says that identify whether it is polynomial or not. Okay, so we will take a pause, we will observe it carefully, and for checking polynomial, one condition also, okay, you must note it down, that each and every variable must be sitting in the numerator, then only we can check the powers. Okay, so we will bring this x in the numerator, and it will be, can you tell me, Gauri, it will be 2 into x to the power what?
-1.
Perfect. Okay, plus x square plus 32. Now if I am asking you, Gauri, that is it a polynomial?
No, ma'am.
Due to this,
Due to the power minus 1.
Okay, perfect. This is what you this is how we will be identifying whether the given algebraic expression is a polynomial or not. Okay, two condition which is really important. Both the conditions are clear to you, right? Right, Gauri?
Yes, ma'am. Yeah.
I'm going to show you questions that how exactly question you having from here, and you have to answer me whether the given expressions are polynomial or not. Just a moment. And after that, after solving these questions, we will be starting with the that assessment.
Okay, ma'am.
The first one, is it readable, Gauri?
Yeah, ma'am.
Okay, so which of the following expressions are polynomials in one variable? One more thing I must add over here, Gauri. Whenever we are talking about polynomial, this one variable, maybe it is written or not written, we will be thinking about one variable only. Okay, because in class 10 again you will be having a chapter polynomials. Okay, again polynomial in one variable, and even if one variable will be written over there or not, we are going to talk about one variable only. By default, that one variable has to be there. Okay,
Okay, ma'am.
so let's check which one is polynomial and which one is not. First one, is it a polynomial, Gauri?
Yes, ma'am. It is.
Yes. Next one, is it a polynomial?
Um, yes, ma'am.
Next, is it a polynomial?
No, ma'am.
Perfect. Okay, for the second exam, for the second question, okay, I must add over here, Gauri, that root 2 is fine. Okay, we are not checking the numbers, we are just checking the variables. Okay, the power of the variables. So root 2 over here
Okay,
is
ma'am.
completely okay. Even if you are having in any of the example root 2 y square, so you need to check y is inside the root or outside the root. If y is outside the root, well and good. Got it?
Yeah, ma'am.
Okay, so this type of question should not confuse you. 4, is it a polynomial, Gauri?
No, ma'am.
Perfect. Next, 5.
Um, yes, ma'am. No, ma'am. It is not.
Okay, it's not because so many variables are there. And when we are talking about polynomials, we are talking about polynomials in one variable. So, no, it's not. Okay, so far, any
Okay, ma'am.
confusion, Gauri?
No, ma'am.
Okay, so let's start with that assessment. Just a moment, I am sharing another screen. Can you see this screen, Gauri?
Yes, ma'am.
Yeah. Please, question number 1. You just have to start reading from 1. Okay. The previous part is just instruction. So please read from the first. Fill in the blanks you have to do over here. Okay. And as you can see, you just have to fill the blank by comparing LHS and RHS. I am here if you will face any doubt in any of the question, or you know how to solve it but You are not sure about it. I'm here. Okay. Please tell me. You are going to tell me the answers. I'll be filling it over here.
Okay, ma'am.
So, yeah, first one. Take your time and tell me.
Okay, ma'am. Ma'am, is it -5?
Yeah, it is. Okay. Even pen and paper is not required, at least for this part. Next.
Yeah. It's 1. So 0.
Yeah, perfect. Next.
-17.
Perfect. Next.
-7.
Yeah, perfect. Next.
-3.
Perfect. Next.
Can you make that?
Yeah, you can take your time.
Ma'am, it's 6 for first.
Perfect. Next.
Yeah. Ma'am, 6.
Perfect.
Ma'am, first is 1/5.
Ascending or descending?
Ascending.
Ascending first. Ascending will be 1/5. If you, I can see you are, okay, going in the right track, but please check. Write on your paper two numbers. Okay, fractional number. 100 by 2 and 100 by 4. And check it which one is bigger and which one is the smaller. Yes, Gauri. 100 by 2 is bigger or 100 by 4 is bigger?
Ma'am, I got it. How to do it? Give me 1 minute.
100 by
Wait a minute. Ma'am, 104. So bigger.
100 by
Ma'am, we're
2.
asking
Which one is bigger, right?
But yeah, 100/2.
Okay, so if I will say that if the denominator is smaller, then the result will be bigger. It makes sense.
Yeah.
So just now arrange accordingly in ascending order.
Okay. It's 1/50,
Perfect. Then
1/23,
perfect. Then
1/17,
perfect.
1/12,
Yes.
1/9,
Yeah. Okay, you got it.
1.
Yeah, that's it. 1/5. And descending is reverse, right?
Yeah.
Please check the next one. Is it true or false?
Ma'am, it's true.
It's true. And both side you are getting?
72.
Perfect. Next.
Ma'am, it's 302 centimeter.
Can you please repeat, Gauri?
302 centimeter.
302 centimeter perimeter you have found. What is the formula for finding the rectangle's perimeter?
2 bracket L plus B.
Yeah, 2 in bracket L plus B, right?
Yeah.
Our length is 150 and breadth is 1 meter.
Meter. Five hundred centimeter.
Yeah. Please do the next one. It's a linear equation in one variable, which you have learned in the previous class. You have to find the x value from.
Okay, ma'am. Ma'am, is it 5/2?
Yeah, it is. Perfect. Please tell me the next one. Is 90 a perfect square number?
No, ma'am.
It's not. Next one. Uh, Here we need to do the factorization. Z square minus 4z minus 12 we are having. Splitting the middle term. Do you know this method? Yeah, please tell me.
Yeah, ma'am. Ma'am, is it x1 plus x minus y?
Can you please repeat, Gauri?
X plus 2.
Okay, z plus 2.
Oh, sorry, yeah, z plus 2. And z minus 6.
Perfect. Okay, yeah. So yes, these all the answers are correct. Now we are done, okay, with this paper, and we are done with the discussion as well. Since we are having few minutes left, if I will ask you, Gauri, do you know what is coefficient?
Coefficient. Ma'am, I have heard of it. Yeah,
Coefficient.
ma'am. Yeah.
So let me show you that screen. Okay, I will just take a little bit about coefficient and then we will be continuing it in the next class. Just a moment. So coefficient means multiplier. Okay, basically what is multiplied with that term, that you need to check. Suppose I am taking one of the polynomials, since we are talking about polynomials now. Now again and again I'll be taking polynomial, okay? And I will not ask that is it polynomial or not. You should just keep in mind, yeah, okay, that both the condition is fulfilled, it is polynomial. Let's take few example and we will be focusing on coefficients first. So suppose we are having, can you see the screen?
Yeah, ma'am.
Suppose we are having 2x square plus 5x minus 10. If I will ask you, Gauri, what is coefficient of x square over here? Can you tell me?
2.
Positive 2. Okay.
Yeah.
What is coefficient of x over here?
Positive 5.
Perfect. If I will write minus x square plus 10, and if I will ask what is coefficient of x square over here?
Minus 1.
Perfect. If I will ask x 2x square plus 30x plus 5, and after giving this polynomial, if I will ask the last one, what is coefficient of x cube over here? X cube.
X
Can you see
cube.
any x? No. So the coefficient
No.
will be 0. Okay.
Yep,
Again,
okay.
I can show you the mind map. Do you know any number added with 0 is the same number? Yes, just now you have done this, right? Okay. So basically we are thinking that here we are adding 0 multiplied with x cube, and we are not changing the polynomial. Okay, just little bit representation is changed, but our polynomial is same, and due to this reason we are saying that coefficient of x cube is 0. So this type of question you will encounter where you cannot see that variable, still the coefficient is asked. So this is just mind map. Okay, you don't have to show it to anybody. You will just telling them that the coefficient is 0. Making sense?
Yeah, ma'am.
Okay, so I can see you understand coefficient. Let's solve, like, let's answer questions based on coefficient as well. So that from the next class, we will be starting with the degree of the polynomial.
Okay, ma'am.
Question number 2. Please read it.
Question. I got
Write the
question.
coefficient of x square in each. Okay, first one. What is coefficient of x square over here, Gauri?
+1.
Perfect. Next one. What is coefficient of x square over here?
-1.
Perfect. What is coefficient of x square in the third one? Do you know this is
pi/2.
pi by 2? Pi is just a value. Okay, it's just a